Welcome to this lecture about sending and receiving push notifications with the Azure infrastructure and by using Xamarin.Forms on the client side. My name is René, and I will show you everything that you need to know in order to set up a notification hub on Azure, to create a Xamarin.Forms client app that will communicate with a custom backend, which will then use the notification hub to send push notifications across all devices and all vendors. In the first part, we want to talk about, well, what is Azure Notification Hub? How can it help us to make push notification delivery very, very easy? And of course, we're going to set up our push notification hub. Traditionally, if you want to send push notifications out to different devices, you will have to deal with the different vendors. For Apple, that means dealing with the certificates, then talk to a specific endpoint. For Google, you have to set up Firebase and then use their API to send messages. For Windows, well, you have to configure your Windows application. And then if you send the notification and you want to target one Android, one iOS, one Windows device, you will always have to talk to each service individually. With Azure Notification Hub, this becomes a lot simpler. The setup process will just happen one time. However, instead of directly talking to these services, you will put all the necessary information up into your Azure Notification Hub installation. And then you will go ahead and send messages from your own backend or also from your client device if you want that, directly to the Azure Notification Hub, which will then take care of talking to the individual providers. We are here at the Azure portal and we want to set up the notification hub. It all starts, as always, with the big green plus sign here. Let's create something new. We just search for notification, and there it is already in notification hub. It gives us some information what this is all about. No need to read this because obviously the lightning lecture will explain that to you. In here, we enter the name of our notification hub. So just like with any other web project, this needs a unique name. And I just use some fake name here, some notification hub Xamarin. I'm not going to create that. I have already pre-created one that I'm going to show you in a bit, just to walk you through the setup process. This is new here. It's new if you have created other project types on Azure before. They do not necessarily have that input field here that says namespace. And what this is about is I have to provide, well, yeah, a namespace here. And I haven't really figured out whether I should have one namespace for multiple projects or one namespace for explicitly this specific notification hub. I just went with a name here, and that's fine. This allows me to configure the pricing tier. So like I said, I haven't fully understood that. You would use a resource group. We use the Xamarin University resource group. Now look at this. If I select pricing tier here, it shows me the different pricing tiers, free, basic, standard. I can select them down here. However, there's this tiny information up here that says Notification Hub's pricing tier is set at a namespace level. So this means we can configure the namespace and it will influence our notification hub. I then, however, wonder, why do we have this selection over here? So if the namespace is where I set it, why would I configure it here? I just left that to free, and we're going to have a look at this namespace later. So now I would click create, and that notification hub instance gets created. We'll continue after the deployment is done. And we're back. The deployment process has been completed. You see the name of my notification hub here is Xamarin Push Notif Hub. And now about these namespaces. If you look in here, no word about namespaces. However, here it says more services. If I click that, I can just search in here and I find notification hub namespaces. So let's select that. And surprise, it's showing me all of the notification hubs that I have created over time. And here is the one that I just created for this demo here. So I select this, and it says here, this is now the XAMU Push Notifications Hub namespace. And you can add multiple notification hubs into one namespace, and all the settings you you change in here, they affect all the hubs in there. And not only can we select the pricing tier here, you see here I can change the pricing tier. I can also change things like access policies in here. There's nothing set up here, just one endpoint here for this particular notification hub namespace. I don't know. So this is something that I have to investigate, or maybe you know this already from other projects, how and when you would use namespaces. If you know, please let me know. You have my Twitter handle, then just send me a message or send me an email. I'd be curious to know that. Doesn't really make a difference for us here because we want to focus on the notification hub itself. So back here at the dashboard, I select my notification hub and we see what's in here. We have well, the overview where we see how many messages have been sent. We have a little button here where I can perform a test send. Let's have a quick look at that. I can select the target platform, Windows Phone, Windows, Apple, Android, Baidu, and other templates are supported in here. Let's just select Android here as an example, and you can see how the payload changes. Depending on the platform that you want to target, you have different payloads, different formats that are used for the notifications. And you simply test this in here. You would then click send, and it will tell you which devices could be reached. Currently, that's not going to do anything because we haven't set up anything. Now back to the dashboard. Yep, I want to discard that. Just want to show you what's in our notification hub here. Of course, we can delete it. We have, well, logs going on, diagnosis, different properties, etc., etc. Here is one that we will have to take a closer look at. It's this one here that says notification services. Let me select that. And we see again this list of supported providers. I'm just going to pick Apple here as an example. And notice how here it's asking me for information about my Apple notification service. So Azure Notification Hub, as we learned, is really just something that sits between the vendors, push notification servers, and our devices. It is what is talking, in this case here, to Apple servers. And to be able to do that, it needs certain ingredients. So depending on the setup that we use, we have to provide that. Google has something else. It wants an API key. Now, if you look closely, you see how it says Google GCM in here. We will not use that. We will use Google FCM, Firebase Cloud Messaging. However, that is compatible with Azure Notification Hub. So not a problem here. With that out of the way, let's switch over and see how we configure the platform-specific services real quick. Let's start with Android because, I mean, why not? I am here at console.firebase.google.com. You need to log in there with your Google account, and everything that I do here now is documented. So you find very, very good documentation over at developer.xamarin.com. I have this up here. You see here Firebase Cloud Messaging. It's in the application fundamentals, under notifications, FCM. So everything is pretty well documented. But of course, I want to show you how to set up our project here. What we are doing here is, in order to target the Android phones or the Android devices with notifications, we need some Google service. That is the service that the Azure Notification Hub is talking to. Now, the interesting bit here is that Firebase Cloud Messaging not only supports Android, it is in itself a cross-platform service. It supports also iOS. But we want to use it to target Android only, and we set up, of course, we set up Apple's server too, and we set up the Windows version, and then target all of these from within Azure. Here's the project name. Everything needs a project name these days, so we call this our XAMU notification Android. And I want to again see if I can put this a bit closer. That's the region. Let's create that project. And that's it. This is what we get. And now we need to set this up to use Firebase. Now we see here, add Firebase to the Android app. Very prominent button up here. That's exactly what we want to do. And it wants bit of information here about our application. One of the things is a package name. We haven't built the app yet, so let's come up with a name. It's very important that they match, so we use Xamarin notification. And I will use the same as the bundle ID on iOS later. Hopefully I remember that. Well, let's just go ahead and register that app. And see how here we can directly download a config file. That is very handy because instead of having to configure our server manually, our connection to Firebase messaging, we can just include this file here into our project, into Xamarin Studio, actually into Visual Studio, still saying Xamarin Studio, and set a specific build action, and it will read the values from this JSON file and add the information in there into our manifest. So if we later add the NuGet package, which communicates with Firebase, all of the configuration values are already there. So nothing manual that has to be done in here. Let me just download that, show you what's in there. Here it is. You see we have a project number in there. We have a, can I zoom in here? Yeah, I can. So project number, we have a URL, all kinds of information. Here's our package name that we configured. So all of this would have to be configured manually, but we have this JSON file. That's great. So we save that away, and now let's continue. I get some Gradle instructions. We don't need that. That's Java specific. And here we are. And let's have a look at Apple's service. Here I am at developer.apple.com. I'm logged into my account. And we start by creating a new app identifier. We could turn that process a bit around by first setting up our client application and configuring the bundle ID in there, and then maybe use some magic tools like Fastlane. But I really want to show you the process that is involved here, setting everything up so you understand what is really required to make all of the notifications work. We start with the app ID here. Our app needs a name, so we maybe call that XAMU Notif Apple. I called the other one XAMU Notif Droid or Android. This one needs an explicit app ID. Whenever you want to use some of these app services down here, you need this explicit ID, and while we are there, let's just select push notifications. Here it is. That's exactly what we're looking for. And then we create a bundle ID. I use the name, make that all lowercase here. Notification Apple, and prefix that with com.xamarin.xamu notification Apple. Looks good. Let's continue. Let's see if it's happy with that. Yep. We want to register that app ID and click done. Done sounds a lot like we're, well, done, but unfortunately we're not. This is only the first part. We now say there will be an application, and that application will use remote notifications. So where is our application? Here it is, XAMU Notif Apple. Next, we have to generate a certificate. Now, why that? Well, it's Apple, of course, lots of certificates everywhere in security. But that certificate is necessary to make push notifications work. So let's select development here. So you would create two, one for production, one for development. We click add and say we want a certificate for the Apple push notification service. I have two options here, development and production. We're interested in development, so that's pretty much it. Continue. We have to select our app ID, the one that we just created. That's it. Continue. And now it's showing me some instructions. It wants me to create a CSR file. Now, it's not that we just fire up Visual Studio Code and save some file as CSR. No, that is a certificate signing request. What it wants us to do now is to run the keychain tool, and then we just go through the instructions here. We use the keychain access menu, certificate assistant, and we select request a certificate from a certificate authority. That's it. Go over here, use the email address that is registered with my account here, my Apple ID. Common name, that's my XAMU notification Apple key. CA email address is supposed to be empty. Let's save that to disk. Continue and save that on the desktop. Yep. This has been saved. And again, a done button. We're still not done. Instead, we switch back to the browser. Continue up here, and we have to upload the generated file. So I find that on my desktop. Here it is, certificate signing request created just now. I select that and continue once more. It says, ta-da, your certificate is ready. We now have a certificate with a private public key pair, and we will need this certificate in order to communicate with Apple's push notification server. In other words, this is something that we have to upload to the Azure Notification Hub. So let's download that for now and save it. Next, we need to create a provisioning profile for our app. So let's check the profiles. The profile on iOS is what combines the certificates, the information about the devices that the app will run on, and of course the app information itself. It's like a bundle for all of these things. We want to create one here for iOS app development. Continue. Pick our XAMU notification Apple ID here. That's the one. And I haven't created a dev certificate yet. So you see, I really cleaned out my my development account here for this demo. So I want to create a certificate first. And we want to create one for iOS app development. Now notice the difference, not for Apple push notification services, just for development. And it wants me to have to go through the same process again, but for a different purpose. What I do instead now is the following. I'll switch over to Xcode and let Xcode handle that for me instead of repeating this. Where's Xcode? Come on, Xcode, I see you. There we are, Xcode, preferences. Here's my account, manage certificates. I can just use this here and say iOS development, create one. And you see it has now created one for me. I can probably delete this one here, which has been revoked. So you would not have to do that. Just to make that clear, I did this to show you what is there, what you have to create. So now if I go back here and I look at my certificates, there should be one. So that's the one that Xcode just created for me. Now that's cool. We go back to the provisioning profiles, repeat that, iOS app development, continue, one specifically for our app ID, continue, and select our certificate, our dev certificate. And I want this to run on all of my devices. And give it a profile name, XAMU notification Apple profile. Continue. Now I can either download it or I can go back into Xcode and just open this again, and it should pick it up optimally. Not sure if it did. Download manual profiles. And well, I just hope it did. We'll see it later if we create the application, if I'm able to select it. Otherwise, I can just download it now and we can import it if we need to do this later. So that's been the iOS part. Now, third platform that we want to support is Windows. So let's switch over there. For Windows, it's almost as complex as it is with iOS, believe it or not. First of all, you must have a dev account. If you head over to developer.microsoft.com, you might find the link, or let me just tell you what it is. It's /store/register. So you should have the ENUS or DED there or whatever, /store/register. This is where you can register as an app developer. Luckily, I'm already signed up. Here you see $19 cost involved in here. I'm already signed in, so I don't need that. So the important bit is that you have that account. Note, if you have a Microsoft account, if you're watching that, a Microsoft employee, you cannot use your company account. It has to be a different one. So that's, for now, all we have to do. And instead, I switch over to Visual Studio, because that's now the nice part here. Most of what we do next is manageable through Visual Studio. What I have here is just a plain vanilla Xamarin.Forms solution. We see we have the Xamarin.Forms project, Android, iOS, UWP, and I haven't changed anything. This is what will become our notification client. But here in the context menu, I can select Store, and in Store I can associate the app with the store. And if I do that, it walks me through the process of setting everything up that I need in order to get push notifications to work, besides other things. So here we see there's a wizard. It says here's a couple of things that it will do for me, like set a display name and copy this left and right. Takeaway, it's a wizard. Wizard has a next button. Let's just click next. Notice how here it's trying to log me in with my Microsoft account. I exactly don't want that, because I want to use the private one. I'll just go. And it's done. You see here, there's other tests that I have done before, push notification tests, to just verify that what I tell you here is working. And we reserve a new name here, and we call this our XAMU notification Windows. Now we have Android, Windows, and Apple or iOS. Let's see if we can reserve that. It verifies now that there is no other application around with that name, and that was a big success. We select it here, click on next, and you see now we get all this information that it wanted. It says here's our package display name, it has got a publisher ID and whatnot. So let's just connect this project here with that store application. Well, maybe you spotted it down here. It said create a certificate. So all of this has been done. And now here's the thing. Now we go back to the browser, and we don't want to register as an app developer here. Instead, we select the dashboard over here, developer.microsoft.com. And if I do this, I have to review the terms. Yes, no, not now. Skip the tour, close, all good. Here we have an overview of all the applications that we have, and we should see the one that we've just created. And here it is, XAMU Notif Windows. That's exactly what we want. I can select this in here now. The notifications are pretty well hidden. We would expect them to be here under services, and I think in the past they were, but they are no more. Instead, they are here. Very obvious. WNS, MPNS. Doesn't sound like notifications at all, but that's the title. Push notifications. Great. Now, the first time I came here, I was like, what? Drag your certificate here. And I started to investigate, where would I get a certificate from? What is this all about? Until finally I realized that's totally not what I want. So MPNS, Microsoft Push Notification Service, is for Windows Phone. What we want is Windows Push Notification Service, short WNS, which is what we would use for our UWP app. So sometimes it helps to just read through the information in here, and there is all kinds of information, and this link here is what matters. It takes us to the live services side. So we just go there. We end up at apps.dev.microsoft.com. It logs us in. Hopefully it's using the same account. Let me just double check. Yeah, that's it. It's correct. And we need to register our app over here. Yes, again. So the first one was the association with the store. This is now the app registration. Now we see here it picked up our name. That's great. And we have some application secrets, some OAuth stuff, and we have a package SID. Now, this one here and that one, these are the credentials that we will have to put over and paste into Notification Hub. Oh, that's cool. We save that for now. And we'll get back to that in a bit. Quick recap of what has happened so far. We have now set up our Push Notification Hub instance on Azure. Then we have configured all the native platforms, or to be more precise, the server side, to support push notifications. We first configured Android, then iOS, and finally Windows, which made us create the Xamarin.Forms client project in one step, because it's convenient to configure that through Visual Studio. With all these in place, we now go back to the Push Notification Hub on Azure and select the Notification Services tab over here. Because now Notification Hub needs the credentials for the native providers. And I will do this in exactly the same order. We start with Google, and I said that before. See how it says Google GCM here? That is Google Cloud Messaging. That kind of confused me in the beginning, because I said, is Azure Notification Hub not supporting the Firebase Cloud Messaging, which replaced the old Google Cloud Messaging? Now, really, it doesn't matter. The APIs that Google provides, they're exactly the same. Essentially, for us, it means we can think of that as if the service has been renamed. That's pretty much all it means to us. We just have to provide an API key. Where to get that API key from? Well, there's a nice icon here that says it's used to authenticate with Google Cloud Messaging or Firebase Cloud Messaging. We have to register our app. Well, we did that. Remember that from the beginning? Which means we go back to console.firebasegoogle.com. Here we are in our project. That's the one, XAMU Notif Android. If it's not the one, well, then please select it up here. And then it's a bit hidden. You see this gear here with this beautiful animation. You select that and you would go to the project settings. In case you're not, this takes you to the screen that I'm currently on. And now if you look at that page, you find all kinds of IDs and keys. And in the beginning, I completely overlooked the part that I was really searching. Here it says Cloud Messaging. This is a button, or it's a tab. Now select that. And in here, well, there's the server key. That's the magic ingredient that we need. And it conveniently has a copy button. So we copy that into the clipboard, go back to the Azure portal and paste the key in here and save. Updating Notification Hub, saved successfully. That's number one. Now we have Google or Android configured. Well, if you exit and you go back in here, you see it has saved the API key, which means now Notification Hub can communicate with FCM. For iOS, it's a different approach. We're back to this list here. We select Apple, and there's two different authentication modes. I have not used the token-based one, I have to admit. So last time I tried, this was not there. I don't know if that's new. Have to figure that out. We use the one that is certificate based, so we switch over here and it wants us to upload a certificate and enter a password. So the question is where to get that from. Well, if you remember, when we created the app or the app ID over on the dev portal, we had to create two certificates and we had to create a certificate signing request to set up push notifications. And after this process, we were able to download this certificate here, which was called apsdevelopment.cert. Now it's very tempting to upload that certificate here, but that's not how it works. Instead, we are supposed to import this certificate into the keychain, and we do this by double clicking it. That imports it. And now if I go to my certificates, we will find it, and it is this one here. Notice the name. Apple Development iOS Push Services com Xamarin XAMU Notification Apple. We created the certificate signing request, and in response, as a response, we were able to download the certificate. This means now my keychain here, it contains both the private key and the certificate. So this is really what we need now. We want to export this now. Kind of strange, huh? Export that. We call this our push cert. .p12. That's good. Let's save. I'm saving it to the desktop. And I give it a password. And confirm. It asks me, want to export. Yeah, I allow that. That's fine. Now, this is what we want to upload here. So I select this in here. Select desktop. Select the push certificate. Upload and enter my password here. Remember, what we configured was sandbox mode, not production. Now let's save. And Notification Hub updated successfully, it says, and it created this certificate thumbprint, which tells us that this operation was successful. Now, who's next? Next is Windows, well, not Windows Phone. You see, I'm starting to hover the wrong one. We want to use Windows WNS. That's it. Select that. And different set of credentials. Again, you can hover here, see where this is coming from, package SID and the security key. For this, we head over to apps.dev.microsoft.com. This was the application that we created, and in there we find an application secret. We can always regenerate a new one in case you, I don't know, maybe you created a lightning lecture and exposed it to the whole world, then you can create a new one and change it. I don't really care, I'm going to delete all of this later. So we go back here, and now that's the security key, if I remember. Or did I paste the wrong one? Let me double check. So that's this one, and we are over, here it is, package SID, exactly, that's the other one. Here we have the package SID, that's the other long string that we need, starting with msat. So both of these can be found at apps.dev.microsoft.com. Going back here, package SID. So these two credentials are needed for Windows. Saving, updated successfully. And now the Notification Hub is perfectly configured. It's working. We could even try and test send just to see what happens. And we have configured Android. We just click send here. I don't expect anything. It says successfully sent, which is good news. That means at least there was no communication error. But of course, no devices are registered. Well, let's try Apple here. You see the different payload. Some JSON format, successfully sent, and we have Windows here, also good. I wonder what happens if I select one that I did not configure. Let's select Baidu. Yeah, failed to send, that's good, because we did not configure it, just to verify that Windows Phone, yeah, also throws an error. So that's good news, because it tells us the ones that we configured, they have been validated. Communication with the native service seems to work, which means we're done here, and we switch back to Visual Studio and focus a bit on the client. And we also still have to create a custom backend where we send messages to, and then our custom ASP.NET backend, it will communicate with Notification Hub, that will communicate with the native service, they will push it to the device. So lots of work ahead. And we're back to our Xamarin.Forms application, which I have tuned a bit. If you look at the Android version that is running here, we see that I added a bunch of UI elements. So let me quickly open the XAML file so we can match this up with the UI here. We see that I have added a label, which we will use to display received messages. So that's going to show us everything that's coming in. And we also want to send messages. That's why we have this entry field here with a button which allows me to send. Our focus is on the native project anyway. We see we have the Forms app, and there's one other thing that I put in here. If I look at the app.xaml.cs, I put a little string constant in here, a notification received key. This is just a string because I'm using in here in the main page, I'm using the Xamarin.Forms messaging center, and I'm subscribing to a message named app.notificationReceivedKey, which is sent by any object. What this does is it handles the messages that are received by the native platforms. You remember, we have set up Firebase Cloud Messaging, we have set up APNS for Apple, we have set up Windows notifications on UWP, and all of these messages, they have to be handled in native projects. They will then send out information through the messaging center in order for us to pick it up and display the notification in our Xamarin.Forms UI. That's just what it does here. It updates the text property of our label in the UI. And we want to start by implementing this here in our Android project. The first thing that we have to verify is our application name and the package name. The app name, well, that's what's going to be displayed to the user. Let's just remove the dot here. XAMU Android. And the package name, that has to match whatever we have set up over in the Firebase console. So if I go there and look at it to check our name, here it is. We named it com.xamarin.xamarin.notif. I'll copy this package name here and go over here to my Visual Studio and paste it. If this name does not match, then sending and receiving push notifications will not work. That's number one. The next thing that we need is a NuGet package. No project without adding NuGet packages. So let's add that. Add a manage NuGet packages actually. And we browse and we search for the Xamarin Firebase messaging. Here it is already. That's what they're looking for, Xamarin Firebase messaging. Let's add that. Latest pre-release. That is what I used here. There is also a version that is not pre-released. That's version 40 something. I just gave this one here a try and it worked. So let's do that. Please note that in order to get this pre-release version, you would have to tick this checkbox up here. I want to accept this license, of course, and let it install. It is done. We can see down here how it has finished. That's great. Now there's one more package that I want to add here. That is part of Google Play Services. And if we look now at the packages that have been installed, well, let's not search for something. Let's go down here. We find that there is already some Xamarin Google Play Services, particularly this one here. It's called Xamarin Google Play Services.basement. This confused me, so please make sure, don't let it confuse you. What we are looking for now is something that looks very, very similar, but is called Xamarin Google Play Services Base. Not basement, but just base. This is really a different package that we add here. And we need this in order to figure out if Google Play Services are available at all. So we let that install. Again, accept. With the packages in place, we need our Google Services file. You remember where that's from? Well, if not, then check your browser. And we're here at the Firebase console. Okay, we see here this download button. This is where we can grab the JSON file. I downloaded that earlier, that's why I have it here. And I want to make sure that I add this to our Android project. Let's pull that in. Here we go. Now it has been added, Google Services JSON. And we have to configure the build action for this. So please open the properties and see the build action over here. And notice how the build action here is by default set to none. If you open the drop-down, you look at the list and you scroll all the way to the bottom, you should see something that says Google Services JSON. Here it is. I'm going to highlight that. There is a known issue with Visual Studio on Windows, which results in this selection not being available. So I'm going to pick it here now. And if you don't see this Google Services JSON option, please do the following. Clean the solution, rebuild it, just the Android solution. So you would go ahead and go in here, clean it, then rebuild. Then exit Visual Studio, really close it, and reload the project. The thing is, this specific option that we're using here is only available after you have added the NuGet packages that we have just added. And the bug is that the list doesn't update immediately. What's next? Well, next is we have to do a bit of configuration in our Android manifest. Where do we find that? Well, correct, it's here under properties. There's the Android manifest, and by default, if you double click that, you don't see a lot, just a bit of XML. In here, into this application node, we have to add the configuration that allows us to receive messages from Firebase. And here is this XML. I have to clean it up a bit because you see the application tag is there twice. Let me remove that. We only need the part that starts with receiver. Be sure to paste it into the application node. So it's a child node of application. What's that about? Well, first of all, note that this piece of XML would be the same for any application that uses Firebase Cloud Messaging. You don't have to change anything. The reason is that it's depending on the application ID, which is using a placeholder. So as long as you have $ open curly brace application ID, close curly brace in there, this will work with any app. By doing this, we have really completely configured our app for FCM. This part here, plus the Google Services JSON, that's all the information it needs. Now, of course, we haven't written any code. This is something that we will do next. And to achieve that, we go to our main activity. And in main activity, we want to add something to handle the messages. First, remember that we added this Google Play Services base library. And I have a little helper method here that lets us detect whether we have Google Play Services available at all. It's not guaranteed that this exists on each and every device, particularly if you run this on an emulator. You might find that Google Play Services are not there because they have to be licensed. So it's just good behavior to check. You see there's a bunch of red underlines here. We want to resolve that. It should come up with using android.gms.common. Let's resolve that. Now the errors are gone. So the question is, where are we using that? Well, that's inside our onCreate method. Let's make some space here. That's where we put our check. And here I simply call it. I don't really react to an error situation. You see I'm doing some console write lines here. As the note says here, in a real app, you would have to deal with that gracefully. One of the first things that happen if we use Firebase Cloud Messaging is that we are assigned a unique token. Every device has to be identified, otherwise the messages could not be delivered. That means we need some sort of service. And I just add that in here. You could put that in a separate file. I just paste it all into this main activity here. Let's have a quick look at it. This is the Firebase ID Service. So as the name says, it is responsible for receiving this, well, actually it's an IID, instance ID, and store it. Again, let's resolve that. We see that it's subclassing an existing Firebase instance ID service. We get this class via the other package that we added, the Xamarin.Firebase package. It has got an onToken refresh method, and this is called every time a new token gets assigned to the device. This can happen anytime. Tokens are not guaranteed to last forever. In there, we pick the current token from the Firebase Instant ID's instance. And I have already added a helper method, which we'll use later, because remember, we also want to send notifications. So eventually our token will have to make it to the server in order for the server to be able to register the device, remember it, and send messages to it via the Azure Notification Hub. We're not using it in this first step here. Up here, we see that this service is decorated with the service attribute, and it's registered with an intent filter, and it will react to this specific event or this specific action that is declared in the Firebase library. Once we have the ID, what's next? Well, of course, we want to receive the message itself. That's yet another service that we add here. Here it is. This is the messaging service. Again, see how it derives from an existing class, Firebase Messaging Service. I'm going to resolve that. Here we are. So what is this for? Well, as soon as a message arrives, the message would automatically be displayed in the notification center. So you know, if you look at an Android device, you have the status bar at the top, a little icon would appear there. That's where the messages pop up automatically. So you would not really need that messaging service. However, if your app is running and is currently in the foreground, is the active applications, and you want to react to a received message, well, then you need this service. Otherwise, it's optional. It has one method, which is called onMessageReceived, that contains a remote message object. That remote message object can carry different payloads. Here's one example of what the JSON that represents such an object could look like. This is a classic, notification message. Notice how it has got a body, a title, and a reference to an icon that would be used in the notification center. If you have a message like that, you can use the messages getNotification.body property. If the message is of a different type, then this will throw an exception. That's why I put it in a try catch here. So you want to make sure that you're parsing the messages correctly. For this demo here, we'll stick to simple notification messages, so that's okay here. The next thing that we do here is, we have to handle our message, which in our case means we're simply going to inform our Xamarin.Forms application. What you see here is some outdated code. I want to remove that. Instead, what we do is we use the messaging center. I'm going to resolve that using Xamarin.Forms. And we use a send method. And our send method is coming from an object. It's going to send a string. And now we have to identify our sender. Well, that's just us. Then the message itself, or the ID of the message, that would be, I have to check, xamunotive.app.notification_received key. That's the key that we defined in our Forms app. And the parameter, that is the message that we have just received via FCM. So we pass the message on to Xamarin.Forms. And in our Xamarin.Forms app, it will be picked up by the main page. That will update the label as long as the app is active. Now I'd say we give it a try and run it. The application is now up and running. We can see it here. I'm mirroring my device. In case you wonder why I'm not using an emulator, the reason simply is that I can trust the device better. I know that the device is capable of handling notifications, everything works there. That's why I'm not using the emulators. What we're after here with our first test is we want to look at the output. So in case you don't see it, please open the output pane down here, or use the quick launch up here. Search for output if you don't see it, and select the debug Windows output. And in there, show the debug output, or show the output from debug. That's what you're looking for. If everything works as expected, you will find in there something that says token received. Here we have it. That's what we have in our service. If I go in here, in our Firebase ID Service, that's what we output. And we put the token into the output window. For a quick test, you want to grab this token here, copy it, because we can use this token to send a message directly to our running application. And we can try this first now from within the Firebase console. That's a good first test to see if the native part is working. We go over to the browser, into the Firebase console, and over there select notifications from the menu. We select this new message button. Now we can enter the text for our first message. Let's just celebrate ourselves. You can configure additional options like when would you like to send that? What is your target? You can send messages to individual devices, to all registered devices, to specific topic, to certain users. We just send to a single device for now. And here it wants the FCM registration token. That's why we copied the token from the output window. So I put it in here, and then I'm ready to send. There are a bunch of advanced options which we ignore. So let's send that. It requests me to confirm. Now we switch over to Visual Studio. Here, meanwhile, it says scheduled. And if I go back here to my device, look at this. It says success. Hooray. That's exactly the notification that we sent. So first test was successful. Now let me show you the alternative action. If we don't have our own service, it will deliver the message to the notification center. So I go here to the home screen and try that again. We'll just say app is in background. Again, send it to a single device. Our token is still valid. And let's send it. Yep. And I get over here quickly and watch up here. And notice that little Xamarin icon that has just appeared. This tells us that a message has arrived. And if I pull down here in the notification center, and it says here app is in background, which is absolutely right. I click on this notification and it takes me to my application. If you wonder now, what about our label? Why has this not been updated? Well, kind of obvious. The message was received while the app was not active. That means it did not use our message received method in here. Instead, the message is delivered to the app through the intent parameters. So you could pull the message information from the bundle that is passed to your application and extract it there. With that, we have proven that our application is working. We can receive local notifications. The FCM part is working. There's one little thing that I would like to show you. It's this part here. This is some code that allows you to forcefully refresh the token. Why that? Well, there are situations on Android where no new token will be sent to you, so you don't receive anything. You will easily notice, because if you put a breakpoint down here in the on token refresh, it's not going to be hit and you don't see this output. But the old token is not valid anymore either. And this is a typical debug scenario where we redeploy our app constantly. That's why there's a way to, well, fix that. And that's also explaining why it's put here into the conditional compilation only during debug. You want to make sure to run this on a separate thread, otherwise you get an exception. This may not be run on the UI thread. First thing is to delete the current instance ID, and then just access the instance's token property. If there is no token, it will trigger a refresh. You will end up in that callback down here, and you have a new token. That's Android. Up next is iOS. Here on iOS, I am back in the very same Forms application that we have used before for Android. However, this time we are inside the app delegate file of the iOS project. And just like on Android, we have to write quite a bit of code to make sure that our notifications work. The first thing that we have to do is to request permission from the user. So one does not simply receive remote notifications on iOS. Instead, the user must agree. We got to tell them what this is all about. So I'm going to add a little helper method, which I called request push permissions async. Now, what does this look like? Don't be surprised by the amount of code. It's quite a few lines here. We analyze that. First, notice that there's a comment here that says iOS 10 and later. With iOS 10, Apple changed the API in order to request permissions from the user. Now, I thought iOS 11 is released, and really most of the devices out there should be on iOS 10 and 11. That's why I'm using that one. The older API is not very difficult. You can look that up inside our documentation, but let's just use this one for now. Everything that has to do with notifications, whether it's remote or local, doesn't matter, is now handled through the UN User Notification Center. We can get this via singleton.current, and we request authorization async. We can await that, and we also have to say what is it that we want to do with our app. We want to show messages, alerts. We want to update the badge on our application that says how many messages have been received, and we want to play a sound. By doing this, if you run the app the first time, the user will see a little pop-up that explains what this is about, and they can either confirm or they can deny. In both cases, our application should work. So you should never build an application that crashes or does not run just because the user does not want to use notifications. What is also interesting, we call this every time the application starts. However, only the first time the pop-up will be shown. This is automatic behavior. For all further calls, no UI will be displayed, but we still get a result that says, what's going on? Do we have permissions or not? I'll show you that. The return value of this request authorization async, that's really two different values. One is a Boolean that says whether the user has confirmed, whether they agree to receive push notifications, and the other one is an error. You should check the error first. The default case is that the error is null. Honestly, I don't know what to do if the error is not null, because that should really not happen, right? I mean, that means something went wrong internally in Apple's pop-up or something. So here I just bail out. I presume if that happened in my app, I would just handle it as if the user did not approve the request. If there's no error, we have to check our approved Boolean here. Again, if the user does not approve, well, then no notifications will be received. Our app should be able to deal with that. Here in our demo app, I just return, I don't do anything else. If it has been approved, or if this is a subsequent call, then we have to check a second method here. Let me show you that. It's get notification settings async. This returns you the current settings. So you're not requesting something new, but instead here you now verify, is the permission still valid? Because what can happen is you run the app the first time, user sees this pop up, they say, yep, I agree, I authorize this app to receive push notifications. Then they leave the application, they go into the settings app, and in the settings app, they turn off the permission for notifications for your app. So that means you always have to verify that the permission is still there. And we get back an authorization status. And if that's anything but authorized, well, that again means we cannot work with notifications. For our app means it's just not going to do anything. And finally, if all is good, we call our UI application.sharedApplication.register for remote notifications. That's the important bit here. Now we know the device is correctly configured, we have permission, we can start receiving notifications. Okay, now don't be surprised by the amount of code that I will paste here. Boom, there we go. I'll scroll back up to where we stopped and we'll walk through this. This was our last method here, register for remote notifications. With that, we kick off an asynchronous process. If we register, eventually the device will receive a unique token. So that works exactly like on Android. Let me add a line break here to show you this. iOS will call the registered for remote notifications method and give us the current device token. There are situations where this token can be null. We should just ignore that. But if the token is not null, well, in our case, we just log it to the console because we can use it for test send. And we also send it to our ASP.NET backend, which we still have to build. That's why there's still a to-do in here. Registering for remote notifications can also go wrong. There's another override, which is called fail to register for remote notifications. It means that, well, communication with the server did not work, or maybe Apple servers are currently down, unavailable, whatever. Again, we should deal with that, maybe inform the user saying that notifications are currently not working and functionality is limited. Eventually, we'll hopefully receive our first remote notification. iOS will call did receive remote notification here on our app delegate. And again, I want to put a line break in here so we see better what's in there. We get 3 parameters here. The current application, well, not really interesting. However, the second bit is a dictionary called user info. That is what contains our notification. So in there, we again find some data that we have to extract and then show it to the user. For us, this means forward the information to our Forms app. That's what present notification is doing here. We'll get to that in a bit. Whenever you receive a remote notification, you also get this completion handler here, and you have to call this. And don't let it take too much time before you call it. This should happen pretty quickly. And you have to return a fetch result. You see here, I'm returning no data. There's others that say, hey, something failed, there's new data, or no data. That's what I'm using here. So you could go ahead and say, well, I've received a notification And in response to this notification, I want to download some information in the background, some more data for my app. Then you would return new data here and maybe kick off some download process. Here we don't have anything, so we just call the completion handler. What about present notification? It is extracting data from this user info dictionary that we have here. Just like the Firebase cloud messaging notifications, Apple's messages, they have a certain payload, a certain format, and part of this is a string that's called APS, and there's another string in there in the dictionary that's called alert, and we simply extract that alert string here, which is a key in the dictionary, and try to read the content of this message. So there might be other bits in there. Please refer to documentation to see exactly what this structure looks like and what you can send in there. It can include a title, it can include the actual text, it can include a sound. All of this is possible. And here you see we use again our messaging center and just forward that to the Forms application. But what happens if our app is not running? So it has not been started, maybe the user rebooted the device, and we receive a notification. Well, first, the good news, iOS will, just like Android, automatically display a notification in the notification center. And you know, if you have an iOS device, that you can go to the settings app and, well, set up your defaults, how you would like that to be displayed, whether it's a banner or it's a modal dialog, but it will appear. Well then, if the user taps that notification, our app will be launched. Now we have a problem because we want to know, well, what was in that notification. And we get this from the options parameter here of our finished launching method. Now, if you look closely, you see that I'm storing these options here in a field named launch options. Why that? Well, the reason simply is that I'm gonna parse the content of these launch options in our onActivated method. OnActivated means the app is now ready, it's there. It also means that our Xamarin.Forms framework has been initialized, so we are ready to update the UI. Now there's a little check in there. I see if there have been launch options, and if those launch options contain a specific key. That key is called UI Application Launch Options Remote Notification Key. If that's in there, we read that key, and it is an NS dictionary. So that NS dictionary is the very same one, or has the same structure as the one that we receive in our, where is it, down here, there it is, did receive remote notification. And for us in our app, this means we're just going to pass this dictionary to the present notification, which will now update the UI. So that's the case if the app was not running. With that, we're done code-wise. There's a few things that we still have to check. We go to our iOS properties in here. Make sure that here in the signing section, we have selected the correct profile. If you remember, we created a specific profile here for our app. Apparently, it has been picked up correctly, and we have to select that. Then we go back here to the info plist file, just double click it. And in application, we'll configure a proper name. I just keep the XAMU notif. Then we need to set our bundle identifier correctly. This bundle identifier must match what we have configured in the dev portal. If I go back here, check the dev portal, here's our app IDs, and I use this one here. We see that that's the correct com.xamarin XAMU notif apple. That's fine. And finally, depending on which APIs you're using to request permissions, make sure to set the deployment target. I set it to 10 here because that's the minimum version that I'm going to support. Then we move on. Up here, we see capabilities. And under capabilities, we select background modes. In order to receive remote notifications, you must check this here. If that checkbox is not set, you will not receive any notifications. With all these in place, we should be able to deploy this. I'm going to run it on my iPhone and mirror it to the screen, and we receive our first notification. And here the application has been started on my device. So this is mirroring the iPhone. And we can clearly see the first time the app is run, iOS will automatically present this pop-up here. And it tells us here exactly what we configured. Notifications may include alerts, sounds, and icon badges. Now I just confirm here, say, yep, I'm fine with that. I have allowed it. And now we can look here at the log files. So I'm using Xcode log here and see if we can find the token in there. Let's just search in here. I should probably not search for token, but for token received, because that's what we had in the code. And here it is, token received, exactly. See, Angular bracket opens here and goes all the way to the next line. I highlight it here and I copy that. Now we want to send a test notification. Apple does not have a web-based UI to do that. Instead, well, you would have to send it manually, but I found a little utility which does that. It's called Pusher. So here you see the About box, you find that on GitHub. I put the link into the README file of the repo that belongs to this Lightning lecture. How does that work? Well, first we open this drop down here and it will detect the certificates that we have installed. If you remember, when we set everything up, we created this push notification certificate over on the developer portal. We downloaded it, we imported it into Keychain, we exported it again, we uploaded it to Azure. So that's exactly that one here. It detects that, I select that. I can reconnect here. It says connected, all good. And then I'm allowed to paste the ID here, that token. And down here you can see the payload. Here's the APS string that we looked for. Here's the alert key. And here the value of this alert, that's the message that it will send. So I'm going to change that here. It says, just like on Android, success, hooray. Now I push this, I send it, and please see over here what happens. Push that. And it says, success, hooray. We have received that message while the app is in the foreground. Notice there was no notification ban or anything. Now we give this another try. I go to the home screen here on the device. Here I am. And we try this again. We say success, hooray, still. And look over here. I see the notification appears. I can click that notification. I can tap it. And it takes me to my app. And it updates the UI as expected. That means our native implementation is now working. We still have to get the UWP up and running now. And then we're finally ready to also send notifications via the Azure Notification Hub. Again, running another project, this time the UWP version. You see, similar UI. Let's see what we have to do with regards to push notifications. And you'll be pleasantly surprised how easy it is to include push notifications into a UWP app. We just want to open the app.xaml.cs file here and go all the way down. Here it is. And add a little helper method which initializes remote notifications. I got to resolve the namespace here for task. And we need the push notification channel manager. So I resolved that too. Everything is already there. Big surprise, no NuGet packages to be added. So what's going on here? In init remote notifications async, we create a push notification channel for application async. Clearly Microsoft competing here with Apple over the longest method name, but yeah, still way to go. What are we getting back from this? Here we have it, just says channel. Well, the channel really is the token. This identifies the app on that device. And we can use the channel to wire up an event that is called push notification received. So we simply add some handler in there, and just like before on the other platforms, we also log this on UWP. There's no console, just use debug writeline here instead. Now let me add this handler here, and of course we want to call this init remote notifications method. We do this from, where is it? From here, from onLaunched. See, there we are on launched method. Down here, I say init remote notifications async. Way to go. What about our handler? Well, let me bring that in. Here it is. Let me put that on a new line. We get the sender and we get push notification received event arguments. That's what is interesting for us here because they contain the actual notification. There are different types of notifications. Again, you find more information about this in the links that I provide in our repository in the README. There are toast notifications, there are data notifications, and depending on which notification you're dealing with, you will have different content. Here, I assume that all notifications will be so-called toast notifications. They have a content property, they have got an inner text property. I extract that, and this is what I forward to our Xamarin.Forms application. But there's a little other thing that I think we should fix here. Here, I just called init remote notification async. I think we should really await that to make that happen. Change this one here to be async. Well, let's see if this builds. It's running. We look at the output and we're searching for our token. Here it is. Even highlighted from my previous search, received token. I copy that. And if you look at it closely, I'm gonna zoom in a bit here. There we go. See how this is an actual URI. HTTPS db5 notify windows.com, and there's a token. So unlike on the other platforms where you get a token and then you talk to a hard-coded server and send that token, here the token itself is already a URL. So we are communicating with that token, with that endpoint directly. Again, if we want to test that, we need some help. We could either just post something to that URL, or we're using a little helper. I found one that's at pushtestserver.azurewebsites.net, and if I highlight it, /WNS. Again, link to that is in the README file. And this allows me to paste the channel URI here. That's the token that I have received. Then it wants the security identifier and the client secret. Now, if you don't remember where to get these from, you would log into the Windows Dev Center, which can be found at developer.microsoft.com. Under App Management, WNS, MPNS, there's a link that says visit the Live Services site. If you go to the Live Services site, you end up here. Actually, you end up at the dashboard with all of your apps, and there you find the secret and you also find the package ID. So let's give this a try. Go back here. We just use one of the built-in templates. Here you have this drop down, and I said we expect toasts, right? Here you see, you better select toast, otherwise we don't get the expected data. That's the template for toast notification. Here you see it's using a binding template to toast text 02. That defines how the text will be formatted. Again, link for more details is in the README file, and we just replace the headline text here saying hooray, and our body text will be success. Now let me send that push notification. Go over here to our app, and you see hooray, success, it has arrived. Now what about notifications if the app is not in the foreground? I have to disable the quiet hours here on my device to see that. And I simply send the message again. And look down here, hooray, success. It appears, and if I click that, well, it takes me to the app. And that's UWP. Easy, huh? So that's good, saves us some time. I close this here. And now let's bring in Azure Notification Hub. We want to be able to register our devices with Notification Hub, and we want to be able to send notifications. There's different ways to achieve that. You could go ahead and just use the REST-based APIs that are available for Notification Hub, and directly from within your device trigger the registration and perform all the sending operations, all possible but not very common. Instead, you end up creating an Azure mobile app. And this mobile app, it handles the registration and it handles the sending part. So the sending is the job of the server, which communicates with Notification Hub, which talks to the native push notification servers, and they send the messages out to the clients. So we start by creating such an Azure mobile app. In case you wonder where to find that in Visual Studio, let me go back here. You see this is in the cloud section, ASP.NET Web Application Net Framework. And if you move on, it gives you this option. I'll cancel here and switch over to the project that already exists because creation takes a bit. Here it is. I called it xamunotif.backend. And I want to start by investigating the NuGet packages here. I just manage them and show you what's in there. Scroll a bit down here. We find that it already contains the Microsoft.azure.mobile.server.notifications package, and it also contains Microsoft.azure.notification hubs, which means it gives us everything in order to deal with push notifications. That's great. Let me close this. And we have a look at the controllers folder. Out of the box, you get 2 controllers, which you don't need because we're going to add our own. Have a quick look at that. Values controller, to-do item controller. If you would like to learn more about this project type and the controllers in there, what you can do with that, please have a look at our Xamarin University Azure classes. I'm simply going to assume you are a bit familiar with Web API. So I will add a new controller. We would just right click here, add, select controller, and use an empty Web API 2 controller. I've pre-created that, so instead I just show all files and include this one here into the project. Close that, and go back here. My XAMU notification controller is an API controller, which I expose at the endpoint /XAMU notifications. It reacts to HTTP post, and it allows me to send a notification. Here we have it, send notification async. And I try to keep it simple, so my notification is really just a message. Maybe your application needs additional content like a title or an image or sound. You can of course change that. This one will call the internal send notification async method. This is the method which is now supposed to communicate with Notification Hub and send out the message. So how would we connect this backend now to the Notification Hub? Well, simply by using the NuGet packages that we just looked at. They allow us to create a client object. Here we have it. This hub object that I have here is the return value of Notification Hub client.create client from connection string. This uses a Notification Hub connection and a Notification Hub name, which we don't have yet. So let's see where we can get that from. The Notification Hub name is easy. If we just go to our push notification hub in the Azure portal and look at the overview, we find the name right here. It's Xamarin Push Notif Hub. The other piece of information that we need is some secret, some access key. We find that in here where it says access policies. Let's select that. And we find 2 of them pre-created for us. A default listen shared access signature and a default full shared access signature. They're used for different purposes depending on what you want to achieve. The first one is meant for read-only access of Notification Hub. Definitely the wrong one for us because we want to be able to also send notifications. So we will need this one. You would copy that and paste it over into Visual Studio. Here I have prepared something which we can add. Notification Hub name, our name, and the connection string from the access policies. With that, we can create our hub. That's all good. And next, we need to send the message. So what we need is the information about, well, which devices have actually been registered and what's the message format for them. Remember, every device, every vendor has got a different payload. So we need to find a way to send our message to all of the different devices in one go. And here's where Azure Notification Hub really shines because we don't have to worry about this anymore. Instead, what we use is a template. Here we have it. Every device that registered, and we will get to this bit later, it registers with its specific payload. So for Windows, that would be some XML. For iOS and Android, that's a specific JSON format. And in this payload for every platform, we put a placeholder. And we will call this placeholder message param. And if we now send a message through Notification Hub, we just say, no matter which device, which vendor we're targeting, just replace message param with the actual message. With that, all that is left is a call to a send method. And we have that here. Notice how our hub object, our client, it has got a send template notification async method. And all we do here is pass in the template params. It will then look at its internal database and it will figure out, okay, device 1 is an iOS device, that's the payload, that's the template that has been registered. It will start looking for the message param placeholder in that iOS template, replace it with the message, and send that over to Apple servers. Next device might be Android. Same thing. Gets the template, which is Android specific, replaces, and sends it to Firebase. Easy as that. We just have one call here, and it might send out the message or the push notification to hundreds or thousands of devices. We still have to fix the return value in here. And I want to spend one more word on sending out to hundreds or thousands of devices. Up here, notice how there's a Boolean that says enable test send, which is set to true here, and there's a comment in here. You should really only set this to true as long as you're debugging. If this is on, if this is enabled, the result value that you get here, it will tell you exactly how many devices have been reached, how many devices failed, what was the error. However, it limits the number of reachable devices to, I think, 10, which of course is nothing in a productive environment. So you want to make sure to set this to false the moment you publish it to Azure and try to use it under real conditions. Another thing that you notice, we still have some red underlining here saying config is unknown. I will add that because there is a nice feature that we haven't discussed yet. And this feature is about avoiding these hard-coded names and connection strings here. So let me show you that. If we publish our backend solution here by using publish, we bring it up to Azure. I skipped that part. We can do something very nice. So let's assume this has been published. Cancel here, go back, and I switch to the browser. And we'll look at our published backend service. We will find a menu entry that is called push. If we select this, we can now connect our backend service, our Azure mobile app, to an existing notification hub. Here it has already been connected, so that's why it only offers me disconnect. But if you look down here, it says notification hub, Xamarin push notif hub, in that push notification hub namespace. Going back into Visual Studio, we can then use this, if I go down here, this still missing config object to get the information about the notification hub. So let me add that. And here it is. Scrolling back. Our config object is an HTTP configuration. In that case, we can get the mobile app settings provider and from there go directly to all the settings that have been created over in Azure. And one of these settings is our notification hub name. And the other one is, you probably guessed it, our connection string. What this means is, as long as we are running this service here over on Azure, we can skip this part here. We don't have to hard code the hub name and we don't have to hard code the connection string. The problem with this approach, however, is that if we run our service locally, these settings are not available. So that's when we want to use that. The way I solve this is by typically putting an, I don't know, maybe an if debug around it, or you want to put an if use config around it, whatever compilation flag it is that you want to use in there. I just comment them out for now. And I use the hard-coded ones because they work on both locally and over on Azure. So that's really all there is in order to send a notification. What we are now missing is the part where we register our devices. And that's what we do next. I'll show you the device registration here on iOS. It's really the same process on all platforms because we have prepared our projects for it. Remember that we eventually receive a token. Here on iOS, it's the registered for remote notifications. Our token is NSData. And we always added these asynchronous methods here, where in the beginning I said we still have to implement them later once our Azure Notification Hub is set up and the backend has been set up. Well, that's the case now, so we can do this. Which means on all platforms, we will have to go in here and somehow transport our token over to the Notification Hub. Again, we could talk to the Notification Hub directly via REST API, but it's better to instead talk to our own service and let it handle the registration. And that's what I want to show you here. So the cool thing is that most of the functionality has already been built for us. We start as so often by adding a NuGet package. We manage them here, and we search for the Azure mobile client. Here we have it, microsoft.azure.mobile.client. And yes, this is exactly the same library which you would also use for access to easy tables, the one that we're using in our Azure classes, exactly that one. Here I add that to iOS. I have already added it before. You would do this for whatever project you're currently working with, iOS, Android, UWP. Back in our app delegate, we just add this piece of code here. We can create a new instance of the mobile service client, and I have to resolve that. And you see here that not only does it want me to add the appropriate using up there, it also needs a reference to system.net.http. It conveniently allows me to add this reference in here. You could also right-click references, add reference, and then look at the assemblies and you find system.net.http in here. So that's the same thing. This has been generated. And next we have to tell it, well, where can it find our server? So we need to provide it with the URL of our backend service. I will put this as a constant into our Xamarin.Forms app and call it mobile service URL. So we go up here, make some space in here and paste it there. Here we have it, our mobile service URL. That is Xamarin Push Notification Hub backend.azurewebsites.net. And again, it's important. This is not the URL of the Notification Hub itself. This is the URL of the project that we have just created over in Visual Studio and published it to Azure. And you notice that it's still complaining about something, a missing templates param here. This goes back to what we had over here. If I quickly switch back to the backend code, here we have the controller. And you remember how here we are dealing with templates. We said there must be a template for each vendor for every device that contains this message param. So now it's time to register exactly that template. Let the server know what the template for this specific device is. The code looks like this. The templated message here for iOS is that format. It's JSON based, so we have open curly brace, starts with APS, and part of the content is this alert entity here, and that's what would contain the actual message that will be displayed to the users. Now in our case, that message is the placeholder. Here we have it, $message param. Again, for comparison, over here in the controller on the server, that's what it's looking for, message param. This is the payload for iOS as a template. This is the most basic format that you can use. You can add other information in here, like an icon or a sound that should be played. You find information about the payload over in Apple's documentation. There's a link on our GitHub repo for the code for this project. Next we go ahead and we say, well, we want to register this template. And here's another nice feature. We can register multiple templates. So you could say I have one template that is for regular notifications. I have one template that is for emergencies, which maybe contains a sound. I just say, I name this template here generic message and throw it in there. This is what I then pass to the register async method, which would now talk to our backend and register our device with Azure Push Notification Hub. And you get to this by calling the platform-specific getPush method. And this here on iOS returns something where I can pass in NS data. You do the same on Android. You will get a register async method where you can pass in a string. Same on UWP. If you wonder now, where is it posting to? So this really, it does some REST-based communication over HTTP. It will send this somewhere. Here's the interesting thing. The moment you publish the Azure mobile app up to the Azure cloud, every Azure mobile app will get additional endpoints. And one of these endpoints is what this message is calling. If you're interested in the details, again, I put more information into the README file of the GitHub repo. There you can see the controller behind this logic. For us, it's important that this controller will pick up the registration information and forward it to Notification Hub. Also remember, it can do that because our backend has been associated with the Notification Hub. I'll quickly add the code for Android and iOS, for Android and UWP. And then we also need to add the part where we actually send messages. As promised, here are the implementations for the other platforms. Here is UWP. We add that into the app.xaml.cs file. It's here directly part of the init remote notifications async method, which we already had there. Our template looks different. You see it's XML based, but of course contains our placeholder. Again, there's different payloads, so you can look them up in the documentation. We also need the specific header in here. And then it's business as usual, create a mobile service client. I have added the NuGet package, get the platform specific push framework, and then call register async, and we're done. What about Android? We collapse this, look at Android, main activity over here, same method. Here our template looks like that. Notification contains body, title, icon, and again, our body is the only param that we have here. Store that in the array of templates or in the dictionary of templates. Get push, of course, add the NuGet package, register async, and done. I added one more line here to show you what you can do with the result. Once register async has been called, the push object that you have here, so the return of get push, it contains the installation ID which was assigned to this specific device. So maybe you want to maintain that somewhere or need it, then you can store that off. Right, so now I have deployed the project to all three platforms. I'd say let's try it out. I'm gonna run it here and mirror Android, Firebase. I also have the UWP application here, and over on the Mac I have mirrored my iOS device. So while the apps are loading, let's give this a try over here. I'm back in the Azure portal, and we start with Apple here as a target. And you see that's the payload. I'm gonna just say testing maybe, send that, and indeed this has arrived. Then let's try over here. We want to give Windows a try. Switch that here and say I want to target Windows. Just say test message, or actually what we'll be using, we use the toast message, right? This one here. Send that, go over here, and it appears. And finally, Android. Now that's interesting. I'm going to view this one here. Here it is. And from within the portal, try Android. Here we have to change the message format. I noted that before. By default, it's using a data format. So here you gotta put notification in there. And this one should say body. Then let's send this. It tells us here that it succeeded. And if I look over here, you see that the message has arrived as expected. Now you notice that it's kind of hard to go forth and back between the browser. There's a better way. I mean, we still want to implement this here, where we can send directly from within the app, talking to our backend service. But let me show you something else first. If you open the Server Explorer here in Visual Studio, and in case you don't find it, just use Quick Launch. Just search for Server Explorer, you get it. And you add your connection to Azure in there and you expand it, you will find notification hubs there. And one of these notification hubs, well, that's the one that we are using. Here it is, Xamarin Push Notification Hub. You can right-click this here and select Diagnose. I'll do this. And it will open up with, well, this page here actually. If you look closely, you'll see that up here it says Device Registrations. So let's click that and you can refresh this and it gives you the current list of all registered devices. So this is very useful, not only during debugging, also in a productive environment. You can always see how many devices are registered, but particularly while debugging, you can just say, well, I want to get rid of this one here. I know I registered it incorrectly. You could just delete it. It also filters by platform. Now we have, for some reason, we have 2 iPhones in here, but nothing else. So that doesn't seem to work quite right. It should, of course, show different ones here. Obviously, there is a W and S in here. So I'm not sure why this is not working, but it's a good overview. The other thing in here is Test Send in this tab. So we can send messages directly from within Visual Studio. Now let's give that a try. I say we just pick maybe, what do we have here? Now let's just pick Windows Toast and we just say from VS. We send this. And it says the notification was successfully sent to the push notification system. And if I switch over here, it says from VS. So that's really convenient for testing, for sending out to different devices. But now for the last missing bit, how do we talk to our backend in order to send a message? This will be something which can be purely done inside our Xamarin.Forms project. This is plain HTTP client in action. Let's add some code. And this code will go into our main page here in the Forms project. We start by adding a field, an HTTP client instance. To make that work, you will have to add the correct NuGet packages. So make sure to open the package manager for the solution and add the HTTP package, HTTP client. Here it is, microsoft.net.http. Resolve the namespace, system.net HTTP. Then our base address, well, that's the same mobile service URL that our getPush method is also using when registering a device. So we simply reuse that constant. We say the default headers that we accept. If I scroll over here, that's just JSON. And I adjust the timeout a bit because sometimes it can take a while in order to communicate with the server. And then we have everything we need to implement our send method. In the click handler for our send button, we just generate the content that we want to send. That's a string content based on whatever is currently in the entry field. So we grab that value and we send it over as JSON, push it to the server by calling post async against this specific endpoint, against the XAMU notifications endpoint. You can test this locally or you can test this on Azure. Here, if you look at myapp.xaml.cs, it's talking directly to the published service, but like I said, the local one will work too. Always check the success status code of the result, very important, and handle it gracefully. Here, I'm completely omitting that for the sake of brevity, but you want to check that in your app so the app is not crashing. So let's see what happens. Let's say I run this here on UWP, and I want to check if my Android device is still mirrored. Yes, it is. Here it is. So here's UWP, and here's Android. Let's see if I can get these two here side by side. And here in UWP, we just say we are done. I'll bring Android back and watch over here. If I send, it's talking to our backend. The UWP app receives it. The Android app receives it, shows it over there. And what you cannot see, it has of course also appeared over on my iOS device. Now we can do this the other way around, deploy it to Android and send a message to the other devices. Would work exactly the same way, that's just Forms code over here. And that's it, we have reached the end. You are now able to send push notifications via your own custom backend service to an Azure Notification Hub instance, receive them on all platforms. I hope you liked this course. And we appreciate your feedback or your questions. Please use the Xamarin forums, or you can try to contact me directly via Twitter. Thanks for watching.